Hi there, welcome back to Isabel Explains. In this video, I'll be showing you how to find the minimums and maximums of polynomial equations, no matter their degree. Now, take a deep breath for this one because it's not hard if you're doing it on a calculator, which I made another video about, but if you're doing it by hand, oh boy, I hope you have a cushion wherever you're sitting because this is gonna take some time, but it's gonna be great. Ready? Let's go. As we all know, polynomials are expressions involving x raised to a whole number power, or exponent. If you remember the definition of whole numbers, they are never negative, which makes our lives a lot easier. But if you're working on an exercise that has negative exponents, I recommend you watch my video on rules of exponents so you can turn them into positive first. Alright, let's get to it. There are two possible types of minimums and maximums on every polynomial. They're either relative or absolute. A relative maximum is that point or points on the graph which have a maximum y value relative to those points close to them on the graph. A relative minimum is that point or points on the graph which have a minimum y value relative to those points close to them on the graph. An absolute maximum is that one point on the graph which has the largest y value, and the absolute minimum is the point on the graph which has the smallest y value of the entire graph. Sometimes polynomials are going to have only relative minimums or relative maximums, or they will only have absolute minimums or absolute maximums. I must point out that because the domain of all polynomials is all the real numbers, meaning they go from negative infinity to positive infinity, you can never have both an absolute maximum and an absolute minimum, because that just wouldn't make any sense. Now, I know that finding these points by hand are becoming a thing of the past, but in this video, I'll show you how to find the minimums and the maximums by using your little noggin. I mean, we'll use a calculator too, just not a graphic one. Now, before we get to it, you're probably wondering why in the world would anyone put themselves through doing these exercises by hand when you can just do it on a graphing calculator or on a site like Desmos? Well, I can think of two reasons. One, if you saw the movie Hidden Figures, which you should, you know that machines have limitations and that sometimes when we calculate something by hand, we can be a little more precise than a computer. But seriously though, if you haven't seen Hidden Figures, you just gotta watch it. It is amazing. Okay, the second reason is because some of us just like to use as many neurons as possible in our brains, and this is a great brain exercise. All right, now let's get to it. Let's start with the first example. F of x equals 3x squared minus x plus 7. And you probably noticed right off the bat that this is super easy. This is just going to be a parabola that is going to have a minimum value, and you probably know that all you have to do to find that value is you make the x equals to negative b over 2a, whatever you get here, substitute it back, wham bam done, you get the minimum value. However, that technique only applies to parabolas. It does not apply to polynomials of other degrees. So what I want to show you today is how to find it using the derivative, which is actually going to be applied to pretty much any other polynomial. So let's do it. We find f prime of x, which is the derivative, and the way that we do that is we simply multiply the exponent times the coefficient, and that is going to be my new coefficient, which is 6 in this case, x to the, and what we're going to do is we're going to reduce the exponent by 1. So this is going to be 6x to the first power. And we do the same thing for the next one. This is x to the first power times negative 1 is just 1. So negative 1x to the 0 power, right? Because 1 minus 1 is 0, which turns us into a 1 actually. So this would just be negative 1 and then plus 7. And this is technically an x to the 0 power, right? So this would be 0 times 7, which is just 0. We're going to leave it at that. So the f prime of x, or the derivative of this polynomial, is 6x minus 1. All right, what do we do next? So what we're going to do is we're going to make this derivative and we're going to make it equal to 0. And why do we do that? Well, because when the derivative is equal to 0, that tells us when this original function turns. So whether it does this, right? So it kind of has one of those little turns in here, or whether it goes from going down to then going up, and this would be the turning point right here, or whether it turns from going up to going down, and that would be the turning point right here. So let's do it. So when 0 is equal to 6x minus 1, what we're going to do is add 1 on both sides. That equals 6x, we divide by 6, we get that x is equal to 1/6. And technically, because this is a parabola and we know that it is a parabola, we could just substitute this x straight back up here and get the minimum value, because we know it's a minimum value. But if we don't know if it's a minimum value, when we do it with higher degree polynomials, we have to use this super handy dandy technique. And what we're going to do is we're going to draw a number line, and we're going to test numbers before and after this to see what is the directionality of that graph. And what is the rule for that? Very simple. When f prime of x is less than 0, we know that that graph is going to be moving from left to right down. And when f prime of x is greater than 0, then we know that that original graph is going to be moving up from left to right. So let's try it. So let's start with 1/6, and we're just gonna try out a number before 1/6 and a number after 1/6. So the easiest numbers that come to mind are 0 and 1, right? Gotta keep it easy. So what we're gonna do is just try it out. Let's see, f prime of 0 is going to be equal to 6 times 0 minus 1. 6 times 0 is 0, minus 1 is -1, which is less than 0. Meaning that from left to right up to this point, this graph is going to be moving down. And then we try the 1. So f prime of 1 is going to be equal to 6 times 1 minus 1. 6 times 1 is 6, minus 1 is 5, which is greater than 0. And that is just going to be moving up from left to right after this turning point. All right, so now that we know that it's the minimum, what we're going to do is substitute it back. So we're gonna substitute it on f this time. So f of 1/6 is going to be equal to 3 times 1/6 squared minus 1/6 plus 7. And that is going to be equal to 3 times 1/36 minus 1/6 plus 7. This one is going to simplify to 1/12 minus 2/12 plus 7, which is equal to 6 and 11/12. This is also equal to 6.916 repeating. And if you remember when we did this using Desmos, the answer that we got was actually 6.917, which is a rounded up version of this one. And this is a perfect example as of why doing it by hand, you can get a more accurate answer. All right, so our second exercise is f of x equals x to the 4th power plus 3x to the 3rd plus 4. And the first thing we're going to do again is just find the derivative, which is f prime of x, which is going to be equal to 4 times 1 is 4x to the 3rd power. We'll reduce that by 1. Plus 3 times 3 is 9, x to the 2nd power plus 0. So we're gonna make this equal to 0, and this is 0 equals 4x to the 3rd plus 9x squared. We factor out the x squared, and this is gonna give us 4x plus 9. And this is equal to 0. And the reason why we factor it is because this turns this into a multiplication, which means that either x to the 2nd power is going to be equal to 0, or 4x plus 9 is going to be equal to 0. So if x squared is equal to 0, that means that x would just have to be equal to 0. And if 4x plus 9 is equal to 0, that means that x would have to be equal to -9/4. So we draw our little number line again. All right, this time we have -9/4, which is the same thing as -2 1/4. And then we're gonna have 0 somewhere in here. So we're gonna be using simple numbers again. So I'm just gonna use -3. I'm gonna use -1 here, and I'm going to use a 1, right? Because I like to make my life easy. So f prime of -3 is going to be equal to 4 times negative 3 to the third power plus 9 times negative 3 to the second power. And I'm not gonna do all that in my head, I'm just gonna do it on a calculator, and I'm gonna get negative 27, which we see is less than 0. So which means that going this direction is going to be going down all the way up to this point, the turning point of negative 2 1/4. So we look for the next one. Let's do negative 1. So if we do 4 times negative 1 to the third power plus 9 times negative 1 to the second power, we're gonna get 5, which is greater than 0. Means this goes up all the way to this point. And then we're gonna try it with 1, which is going to be equal to 13th, which is also greater than 0. And you're like, huh? What do you mean? We're supposed to have a turning point here on 0, don't we? Yes, we do. What's going to happen is that this graph is actually going to look like that. So that turning point, it is not considered a minimum or a maximum. It is just a turning point where the graph kind of flattens out a little bit and then keeps going up. So we're not going to consider that as a absolute or even relative minimum or maximum. The only one that we're going to consider is the negative 2 1/4. So if we find the f of negative 2 1/4 or negative 9/4, it's going to be equal to negative 9/4 to the fourth power plus 3 times negative 9/4 plus 4, which is all of this is just going to be equal to, ready? Negative 1163 divided by 256. If we do it on the calculator, we actually get this is equal to negative 4.54296,875. And yes, this is much more accurate than Desmos, because on Desmos we got negative 4.543. And to quote the astronaut from Hidden Figures, I'll take every digit I can get. So here we go. This would be your more accurate answer for this exercise. All right, so in this next exercise, we have f of x equals 2x to the fourth power plus x to the third power minus 3x to the second power. And again, the first thing that we're going to do is we're going to find the derivative function, which would be 4 times 2, which is 8x to the third power, plus 3 times 1, that's just 3x to the second power, minus 2 times 3, that is 6x to the first power. We just don't really write it. So then the second thing I'm going to do is I'm going to make this equal to 0, and I'm going to factor it. The only thing I can factor out of here though right now is x, right? So I have 8x to the second power plus 3x minus 6. And most of you already know that the way that you would factor this would be you multiply 8 times negative 6, which would be negative 48, and then you find the factors of negative 48, that when you add them they give you 3. Well, unfortunately that is not an option. So what we're going to have to do is use our old-fashioned handy-dandy quadratic formula. And when we simplify, we're gonna get that negative 3 plus or minus the square root of 201, and this is 16. Now in this case, I would definitely round up a little bit. When I have to round up this early in the process, I like to keep at least 4 decimal places. So we're gonna have that x is almost equal to, right? This is my favorite math symbol. I call it the ish symbol. It is not, it's called approximate. 6986, and x is also going to be somewhat equal to negative 1.0736. Also, obviously, when we get the x here, the x will have to be equal to 0. So those are going to be my 3 points that I'm going to be evaluating on my number line. So to make our lives easier, we're going to be evaluating very simple numbers. So I'm going to be looking somewhere around here, there's probably a -2, right? There's somewhere around here, there is a -1, right? Somewhere around here, I would use 0.5, which is somewhere in between 0 and 0.69. And somewhere in here, there is a 1. All right, keeping it easy, keeping it simple. So we're gonna do the f prime of -2. You're welcome to pause the video here and do the math yourself, but I'm just gonna give you the answer. It is going to be -40, which means that this is going to go down because the value is less than 0. And then we're gonna look for the f prime of -1, and that is going to be 1. So this is going to be going up. F prime of 0.5 is going to be equal to -1.25. So this is going to be going down. And f prime of 1 is going to be equal to 5, which means that we're going to be going up here. That means that -1.0736 is a minimum, 0 is a maximum, and 0.6986 is a minimum. Now what we're gonna find out is it a relative minimum, a relative maximum? This is definitely gonna be a relative maximum because we know that the graph starts from all the way over here, meaning that this graph is gonna continue to positive infinity on y, and it's also gonna continue to positive infinity here on y. So we know that this is gonna be a relative maximum, but we gotta find out which one of these two is the absolute minimum. So let's do it. All right, so in order to do that, what I'm going to do is I'm going to substitute the f of -1.0736 into the original equation. And you're more than welcome to go ahead and pause the video and do the math yourself, but I'm just gonna go ahead and tell you the answer, which is gonna be -2.0382. Very similar to what we got on Desmos. We just have one more decimal point. All right, so if we do f of 0, this is just gonna be 0, right? 0, 0, 0. And then f of 0.6986 is going to be equal to -0.6468. So this is going to be my absolute minimum. All right, so in this next exercise, we have f of x equals -1/3 x to the 6th power minus 1/5 x to the 5th power plus x to the 2nd power plus x. Whew! All right, that sounds like a lot, but it's actually not gonna be that bad, I promise. So the first thing we're going to do again is find the derivative. All right, now we gotta factor this beast. Well, first of all, what we're gonna do is reduce these fractions, right? That looks a lot better, I think. And remember that what we're going to do is make it equal to 0. So how do we do this? Well, I am thinking that the best way that we can probably try to solve this is by grouping, right? So if we group these, we get -x to the 4th power as a common factor, and that's gonna leave us with 2x plus 1 inside of the parentheses, plus the only factor here is 1, so 1 times 2x plus 1, and bingo, that works because this one is equal to this one. So this is going to be 1 minus x to the 4th power, because we never want to write the negatives first, and times 2x plus 1. Now remember that all of this is equal to 0, right? Which means that either this is going to have to be equal to 0 or this is going to have to be equal to 0. Well, as we can see here, this is actually a difference of squares, right? Which means that this factors even further. So this is going to factor into 1 minus x squared times 1 plus x squared times 2x plus 1. And now if all of this is equal to 0, that means that each individual one of them would have to be equal to 0. So we set them up. This is right, this is an imaginary number, so guess what? We're not gonna use that. All right. Those are my three options, right? So I have -1, +1, and -1/2. So what I'm going to do is I'm gonna draw a number line again. It doesn't have to be super accurate. It's just more for you to figure out what's going on. All right, so I'm gonna use a point before -1. You probably guessed it. I'm gonna use -2, which means it's positive, which means this graph is gonna go up, which means that -1 is a maximum. So f prime of, right here, I'll just use -0.75. Now, I don't really need to know what number that is in particular, because all I need to know is that it is a negative number, which means that it's gonna go down from left to right, all the way to -1/2. So I'll use, for the number between -1/2 and 1, I'll just use, 0. Of course I'm gonna use 0, you know that. That's gonna be equal to 1. And f prime of 2, which is after 1. This is going to be positive, my bad. So this would be a minimum. And we're gonna see if this is a maximum. So f prime of 2 is going to be equal to -75, which is negative. So it's gonna go down, which means that this is a maximum. Now, because the graph starts at the bottom here, right, and continues all the way to -infinity and -infinity here, this is going to be a relative minimum. But one of these two is going to be the absolute maximum. They're both going to be relative maximums, but we're going to find out which one is a absolute maximum. So for that, what we do is we just solve for the values, right? So we have f of -1 is going to be equal, again, you're welcome to pause the video, I'm just going to give you the answers, -0.13 repeating. F of -1/2, which is our relative minimum, is going to be equal to -239/960, and f of 1 is going to be equal to 22/15, which is going to be equal to 1.46 repeating. Now this is clearly greater than -0.13, so this is going to be our absolute maximum. All right, last one. Now for this one, I would recommend pause this video, take a sip of water, stretch your legs, because this one is going to be a little bit different. I'm actually going to be using what we call the rational zero test. I'm actually going to go through it a little fast, so we'll get to it. All right, as always, we're going to start looking for the derivative first. And the first thing that I notice is that everybody has an x. So what I'm going to do is take that x out. Now after this, I have no clue how to factor that, right? So in this case, what I'm going to be doing today is I am going to be using what we call the rational zero test. Now I designed this problem, so I know that it is going to have rational zeros. So if you're not familiar with it, basically what we're going to do is we're going to grab the leading coefficient and we're going to call it q. And we're going to grab the constant and we're going to call it p. And what we're going to be doing is that we're going to be dividing all of the factors of p by all of the factors of q. And that sounds like a lot, and that is because it is. So what we would be doing is we would be dividing plus or minus 1, plus or minus 2, plus or minus 3, and plus or minus 6. All of that divided by the exact same thing. Because these are all the factors of p, which is 6, and these are all the factors of q, which is also 6. Happens to be the same number in this exercise. That's not always the case, unfortunately. So this, if I were to make a list, I'm gonna end up with all of these values. And then what I would do after here is that I would literally just make an XY table, right? And I would test out all of these values. So +1, -1, +2, -2, and so on and so forth, right? All 100 of them, and I would look for the ones that give me a value of 0 for y. Now, because lucky you, I worked this out before this video, I'm gonna tell you which values actually do meet that criteria. I know, do all of that to only find 4 values. But remember, by the way, that we had this x right here. All this would be equal to 0, right? So we would have also 0 for that x. All of these would be equal to 0 as a y value. I'm going to call it y prime so that you know that it's actually from the prime function or the derivative function. And then what would I do from there? Well, I would just draw the number line, hopefully a little straighter than that for you. And I'm just gonna put in all these values, something like that. Like I said, it doesn't have to be super accurate. So what we're going to do is we're going to find, again, values prior to -1, between these two, between, and after 3. Now, because this graph starts at positive infinity on y and it ends in positive infinity on y, I am not going to have any absolute maximums, but I will have an absolute minimum. So let's find out what that is. Now, we know that this is going to be a minimum, so we're going to be comparing this guy with 0, which is 0, and then with 3, which is this guy. Well, this guy beat him by a lot, so this guy is going to be my absolute minimum. Thank you so much for watching. If you found this video helpful, please go ahead and give it a thumbs up, leave a comment, subscribe, ring the notification bell, tell your classmates about my channel, and don't forget that you can send me your questions to isabelexplains@gmail.com. I'll see you next time.